After studying this module, you shall be able to know about the hydrosphere and distribution of water on Earth, understand the various components of water bodies, and learn the origin of various metal ions present in rivers. Hydrosphere. Hydrosphere is a term used to describe the combined mass of water found on, under, and over the surface of a planet. It refers to the discontinuous layer of water at or near the Earth's surface. It includes surface water, which may exist in the liquid state or solid state in form of ice, groundwater, and water vapor present in the atmosphere. The hydrosphere covers about 70% of the surface of the Earth. In his award-winning book, Water, Marc de Villiers discovered the hydrosphere as a closed system in which water exists and says it has been built with the specific purpose of regulating life. The total amount of water, according to him, has not changed since geological times. Water can be polluted, abused, and misused, but certainly not created or destroyed. It can only migrate. Water is the basic necessity for life. It has been referred to as the elixir of civilization. All ancient civilizations have flourished on river plains. Several cities and civilizations have disappeared due to water scarcity. Water is the most abundant substance present on the Earth's surface and is distributed in various forms like oceans, seas, rivers, lakes, streams, groundwater, ice caps, glaciers, soil moisture, and water vapor in the atmosphere. The hydrosphere holds about 1.39 into 10 to the power of 9 kilometer cubed of water. The oceans and seas hold about 97% of the hydrosphere in form of salt water. The dominant part of fresh water is stored in ice caps and glaciers. Only 0.3 to 0.4% of fresh water is found in lakes and streams, while only 0.05% is present in rivers. The water content of wetlands and swamps is about 0.03%, while the atmosphere contains about 0.004%. This trivial amount plays an important role in the hydrological cycle. The Earth's water is not pure but contains dissolved and suspended impurities, which may be inorganic or organic. The movement of water plays an important role in the transportation of these materials on the Earth's surface. We will now discuss the chemical composition of water bodies. Water is a unique liquid. Without it, life is not possible on Earth. Water bodies have a complex composition which includes various gases, minerals, and organic substances. Due to the presence of metal ions, dissolved gases, and other organic substances, different types of chemical reactions like oxidation reduction, complexation occur in water. Atmospheric precipitation is the principal source of the water that makes up lakes and rivers on the Earth's surface. The water is not pure. It contains atmospheric gases and dissolved and suspended mineral matter. The major chemical components which are found in all water bodies are dissolved gases and different ions. Coming first to dissolved gases. They owe their presence in the water bodies to the fact that the atmosphere and the water bodies are in constant contact with each other, and exchange of gases occur between the surface of the water body and the atmosphere. The major gases which are present in water bodies are oxygen and carbon dioxide, while methane and hydrogen sulfide are present in minor amounts. The amount of these gases in water is measured in ppm or milligrams per liter. Aquatic plants like algae release oxygen in water by photosynthesis. This oxygen gets dissolved in water and is called dissolved oxygen, abbreviated as DO. DO is consumed in the process of decomposition of organic matter and organic waste, that is pollutants present in water. Due to depletion of DO, the survival of aquatic organisms becomes difficult. The concentration of DO depends on temperature of water and also the partial pressure and salt content of water. As the temperature of the water increases, solubility of oxygen decreases. In tropical oceans and lakes, the level of oxygen at surface water is lower than at the depth. However, surface water does not become deprived of oxygen as the gas diffuses into water from the atmosphere. The second important gas present in water bodies is carbon dioxide or CO2. The main sources of carbon dioxide in water are from the decomposition of organic waste and by the mixing of carbon dioxide from air. Dissolved carbon dioxide is present as loosely associated carbonic acid. When falling as rain, this slowly erodes calcareous rocks and results in input of calcium salts to adjacent water bodies during drainage. The soluble atmospheric gases enter the water bodies during rainfall. Any atmospheric gases that are soluble in water will pass into water bodies during rainfall. Reducing conditions in sediments result in the production of methane, CH4, and hydrogen sulfide, H2S. These gases are also produced by volcanic processes. After dissolved gases, the other important constituents are metal ions. Many chemical substances are soluble in water. The major sources of solutes are minerals and rocks with which water is in contact. Metal ions in water exist in many different forms, as hydrated metal ions, as undissociated compounds, and also as colloids. Some ions are present in large amount. This include calcium, magnesium, sodium, potassium, and among the non-metals, chloride, sulfate, hydrogen carbonate or bicarbonate, and carbonate. These are called macrocomponents and are present in amounts exceeding milligram per liter. Other elements like borate and fluoride are present in small amounts measured in microgram per liter and are called microcomponent. Calcium ion. It is generally found in the highest concentration. Minerals like gypsum, anhydrite, they are all forms of calcium sulfate, dolomite, etc. are the major source of calcium in water bodies. Calcium ion along with magnesium ion accounts for the total hardness of water. Chloride ion occurs in water samples due to dissolution of salt deposits, discharge of effluents, mixing of sewage wastes, seawater contamination, and flow of irrigation drainage. Chloride ion is present in all types of water. Sulfate ion is present in water because sulfate-bearing minerals are common in most sedimentary rocks. In the weathering process, many of these minerals like gypsum get dissolved in water. Most of the sulfate in water originates from the oxidation of sulfide ores and their dissolution. The oxidation of pyrites, that is iron sulfide, leads to the formation of sulfates of iron and sulfuric acid. Carbonate and bicarbonate. Dissolved carbon dioxide reacts with water to form carbonic acid, H2CO3. This is a weak inorganic acid and it further dissociates to form H+, bicarbonate or hydrogen carbonate, that is HCO3 minus, and carbonate, that is CO3 2 minus. The relative amounts of carbonate, bicarbonate and carbon dioxide are all dependent on pH, and the figure shows the various forms of inorganic carbon at different pH. At pH below 4.5, H2CO3, that is carbonic acid and carbon dioxide species predominate, and almost no carbonate and bicarbonate are found. All components of natural water confer certain properties like salinity, alkalinity, acidity, hardness, etc. Water contains dissolved matter. This is referred to as TDS, which is total dissolved solids, and suspended matter. TDS in fresh water is expressed in terms of grams per dm cubed or milligram per dm cubed. Milligram per dm cubed is also known as ppm, parts per million, while the same for other types of water is expressed in forms of PSU, that is practical salinity unit. We will discuss the chemical composition of specific water bodies. Groundwater. Groundwater and surface water have different characteristics, and the table will show you how these characteristics differ. Now we are discussing the comparison of surface water and groundwater. First, let us take up temperature. In surface water, it varies with season, while in the groundwater, it's relatively constant. Coming to turbidity, again variable in surface water, sometimes high, groundwater low or sometimes nil. Color. Color in the surface water is mainly due to suspended solids, and in groundwater, it's due to dissolved solids. The mineral content in surface water is variable, varies with soil, rainfall, effluence, while in the groundwater it's largely constant. Generally, it is appreciably higher in groundwater than in surface water from the same area. Divalent iron and manganese are generally not present in surface water except at the bottom of lakes and ponds in the process of eutrophication, while these are usually present in groundwater. The DO in surface water is often near saturation level, but it is absent if the water is very polluted. In groundwater, generally there is no oxygen. Hydrogen sulfide is found in groundwater but not in surface water, while ammonium ion is found only in polluted surface water, but it may be present in groundwater. The nitrate level in surface water is low, but in groundwater it may be high. Silica is present in moderate amount in surface water and in relatively higher amount in groundwater. The mineral and inorganic micropollutants can be present in surface water but liable to disappear rapidly once the source is removed, while in groundwater generally they are not present, but due to accidental level pollution it may occur and then it will stay for a long time. Living organisms in surface water include bacteria, viruses, plankton, and in groundwater frequently iron bacteria are found. Chlorinated solvents are hardly present in surface water, but they may be present in groundwater. The eutrophic nature of surface water is increased by high temperature, and generally it's not present in groundwater. As water percolates through layers of soil, it remains in contact with minerals present in soil and gets saturated with dissolved solids. In this process of seepage, it gets depleted of microorganisms present in surface water. The types and relative concentrations of the chemical constituents depend on residence time, solubility, and rate of movement. The characteristics of groundwater are its weak turbidity, constant temperature, chemical composition, and overall absence of oxygen. Circulation of groundwater varies its composition due to pollutants and contaminants present in it. Furthermore, groundwater is often very pure microbiologically. The major mineral constituents come from soluble minerals in soils and sedimentary rocks. The common ions present are calcium, sodium, bicarbonate, and sulfate. Groundwater present in coastal areas contain chloride. Nitrate ion may be a natural component, but a high level indicates pollution. The groundwater in the Ganga-Brahmaputra Delta region in West Bengal and Bangladesh is severely contaminated with arsenic compounds, which are highly toxic, rendering the water unfit for consumption. Now we take up surface water. First, let us see rivers and streams. The chemical composition of surface water is variable through time, and sampling must be done periodically at different places along the stream and river course. During dry season, groundwater contributes more water to rivers, while in rainy season, the major contribution is from runoffs. The composition of river and stream water changes due to pollution. Rivers are dominated by the presence of calcium, silica, and hydrogen carbonate or bicarbonate, which mainly owe their origin from silicate rocks and carbonates. The level of potassium is low due to retention in clays. The dissolved inorganic components may be classified into macro components and micro components. Macro components constitute 90 to 95% of all components in fresh water and include calcium, sodium, magnesium, potassium, chloride, sulfate, hydrogen carbonate, and carbonate. The concentration of micro components are generally up to 1 ppm and includes lithium, rubidium, cesium, bromide, iodide, fluoride, copper, zinc, nickel, silver, lead, and other heavy metals. Dissolved gases like nitrogen, oxygen, argon, and carbon dioxide are also present. Surface water contains nutrients which are limiting factors for growth of aquatic plants. These include nitrogen in form of ammonium, nitrite, nitrate, and organic compounds, and phosphorus in inorganic and organic forms. Dissolved organic compounds generally enter as pollutants. They may increase mobility of heavy metals and influence dissolved oxygen content and flavor of water. The average salinity of river water is low, about 120 ppm by weight. Of this salt content, carbon as hydrogen carbonate and carbonate, referred to as dissolved inorganic carbon or DIC, constitutes 48% and silicon as silicic acid 33%. The remaining 19% consists mainly chloride, sodium, and magnesium in descending order. The composition of river and stream water is controlled by various factors, including water-rock interaction, which is known as weathering, temperature, and human activity. As water interacts with carbonate rocks, the DIC increases due to this reaction, where carbon dioxide combines with calcium carbonate present in rocks in the presence of water to give calcium ions and hydrogen carbonate. You can see that in this reaction, 2 moles of hydrogen carbonate is formed, 1 mole coming from the rock and 1 mole from the atmosphere. With silicate rocks, the reaction can be represented as shown here, where carbon dioxide is reacting with calcium silicate and water to give calcium ions, hydrogen carbonate ion, and silica. This is known as the Urey reaction, and in this reaction, atmospheric carbon dioxide is converted to hydrogen carbonate. Weathering reactions may be congruent, when the entire mineral goes into solution, as the reaction of calcium carbonate with water and CO2, which we saw just now, or incongruent when the mineral is leached and modified to give secondary minerals. The weathering of aluminosilicates to give clay minerals is an example of incongruent reaction, and this is shown in these equations. In addition to weathering of carbonate and silicate rocks, weathering of salt deposits containing halite, that is NaCl, sodium chloride, and gypsum, that is calcium sulfate, CaSO4, weathering of sulfide deposits, and weathering of organic carbon affect river water composition. Temperature is another crucial factor in determining river water composition. It affects rate of dissolution, elemental solubility, and mineral stability. In tropical climates, weathering is more intense than that in temperate climate. The TDS, that is total dissolved solids, in rivers and streams also depends on type of rock. Sedimentary rocks are more prone to weathering than volcanic rocks, which in turn weather more than metamorphic rocks. Apart from dissolved substances, rivers contain suspended materials, mainly silicon, aluminium, iron, calcium, sodium, potassium, titanium, and organic compounds. The average chemical composition of some Indian rivers. Now this table shows the average chemical composition in ppm of the major ions we have discussed in some Indian rivers, and if we look into the table, we'll find that the TDS is highest in river Gomti, followed by river Kaveri. Now coming to seas and oceans. The main source of seawater is river discharge. Seawater has a relatively more uniform composition than river water. It contains by weight about 3.5% dissolved salts, while the same for river water is only about 0.012%. The salinity of seawater is about 35 parts per thousand, of which sodium and chloride make up about 30 parts, while magnesium and sulfate contribute 4 parts. The remaining 1 part is made up by calcium and potassium, 0.4 parts each, and the rest by carbon as hydrogen carbonate and carbonate. 99% of seawater is made up of 8 elements: hydrogen, oxygen, carbon, sodium, potassium, chlorine, calcium, and magnesium, though most of the naturally occurring elements have been detected in seawater. A comparison of the constituents of river and seawater is given in the tables. Now this table shows the average composition of seawater and river water. We find that the amount of sodium in seawater is very high, 468 millimoles per kg, while that in river water is only 0.26 millimoles per kg. Similarly, we'll find that level of all the inorganic components, magnesium, calcium, potassium, strontium, chloride, sulfate, hydrogen carbonate, bromide, etc., are much higher in seawater, and some of these things like strontium and bromine are not present in river water. The ratio of major constituents in seawater and river water is also shown. The sodium-potassium ratio in sea is 45.6, while in river it's only 6. In case of magnesium-calcium ratio, sea it's 5.22, in river it's 0.42. Another important ratio is the sodium-calcium ratio, 45.9 in seawater and only 0.8 in river water. And the calcium plus magnesium with hydrogen bicarbonate ratio, 26.64 in sea and only 0.59 in river water. So we can say in a nutshell that the inorganic components, cations and anions, They are present in seawater in a relatively major amount, but in very minor amount in river water. Seawater contains almost everything. If we do a sensitive analysis, we'll find that every stable element is present in seawater. The amount may be very small. For example, even gold is present, but just look at the amount, 20 into 10 to the power of minus 12 moles per liter. Sodium and chloride ions constitute about 85% of the ions found in seawater. Certain constituents in seawater, like calcium, magnesium, hydrogen carbonate, and silica, are partly taken out of solution by biological organisms, chemical precipitation, or physicochemical reactions. Oceans contain substantial quantities of dissolved elements, complex solutions of mineral salts, and decayed biological matter. The chemical composition of seawater varies slightly from area to area due to addition of fresh water and evaporation. However, this variation is small, and in comparison to river water, the composition is relatively constant. Most of the salts found in oceans are obtained by weathering and erosion of cooled igneous rocks of the Earth's crust and by the dissolving actions of rain and streams which transport their mineral washing to sea. Some of the ocean salts have been dissolved from rocks and sediments below the floor. Other sources of salts include the solid and gaseous materials that escaped from the Earth's crust through volcanic eruptions or that originated in the atmosphere. Now we come to lakes. Lakes are part of surface water bodies, and in contrast to rivers and streams is a body of relatively still water. Lakes are often the storehouse of water that support and the surrounding ecosystems. The chemical composition of lakes is affected by complex chemical and biological processes which occur in the water body. There is lack of water circulation in these big reservoirs, and therefore the chemical reactions that occur on the surface of water are different than those occurring at the bottom. Due to water's unique temperature density relationship, distinct layers are formed in still water, which are shown in the figure. This is called thermal stratification. The surface of the lake is heated by the solar radiation, while the lower part of the lake remains cooled, and this results in the formation of layers in the lake. The upper warm layer is called epilimnion, while the lower colder layer is called hypolimnion. Between these two layers, there is a region in which the temperature changes rapidly. This is called the thermocline. Due to this thermal stratification and poor mixing between the layers, the epilimnion is well provided with oxygen, and hypolimnion becomes depleted of oxygen. When the temperature difference between the surface and the bottom layers is significant, then these layers have different chemical and biological properties. The epilimnion has a higher concentration of DO due to photosynthetic activity of algae and is aerobic, while the hypolimnion has lower DO and more carbon dioxide. During autumn and spring, when the epilimnion cools, the temperature of both layers may become equal. Then the lake behaves as one hydrologic unit, and this is called overturn. The chemical composition of lake water varies due to varying chemistry of erosion products of different lake basins, but the main constituents are similar. That is calcium, followed by magnesium, followed by sodium, and finally potassium. The salinity is computed from the total concentration of ions present, which are sodium, potassium, magnesium, calcium carbonate, silicate, and chloride. The order of abundance of cations and anions is, for cations, as we've already seen, calcium greater than magnesium, greater than sodium, greater than potassium, and while for anions it is carbonate which exceeds sulfate which exceeds chloride. The relative amount of these ions present is shown in the table. The other inorganic ions may be nitrate, phosphate. These are plant nutrients. Metals like mercury, manganese, copper, lead, and organic matter may be present. Under anaerobic conditions, hydrogen sulfide is also present. When aquatic plants take up carbon dioxide and hydrogen carbonate, the pH of lake water may increase, and this results in deposition of calcium carbonate and dolomite. In the absence of any living organism, a lake contains a wide array of molecules and ions from weathering of soils in the watershed, the atmosphere, and the lake bottom. Therefore, the chemical composition of a lake is fundamentally a function of its climate. Each lake has an ion balance of the 3 major anions and 4 major cations. We now discuss wetlands. Wetlands are saturated with water permanently or seasonally. They cover 2.2% of the Earth's surface and contain all elements of the biosphere. The water may be salt water, noted in wetlands along the coastal areas, fresh water, or brackish water. Brackish water has more salinity than fresh water, but less than that of seawater. The dissolved salts present in fresh water is less than 0.05%. In saline water, it is 3 to 5%, and brackish water is intermediate, where the dissolved salt is 0.05 to 3%. The composition of water in wetlands is highly variable and no generalization can be made. The composition depends on their location, that is the wetland adjacent to river, lake or sea, and on the source of water. Wetlands receiving mainly water from the atmosphere generally have low mineral composition, while those acquiring water from precipitation as well as groundwater are rich in minerals, particularly calcium and magnesium. The amount of DO and carbon dioxide is dependent on temperature and atmospheric pressure. The major ionic components in wetlands include ammonium, calcium, magnesium, sodium, potassium, sulfate, and chloride. The minor components are cobalt, copper, nickel, and zinc. The low concentration of the transition metal ions arise due to the fact that they are less sorbed than cations. Many organic compounds are dissolved in water, and thus the total organic carbon or TOC value is high. The pH of the water is variable and may range from acidic to alkaline. Arsenic, if present, is mobile at high pH. The water flowing out of wetlands is chemically distinct from inflow water because a range of physical and chemical reactions occur as water passes through organic materials. Now let us summarize what you've learnt in this module. The combined mass of water found on, under, and over the surface of the Earth is known as the hydrosphere. Now what does the hydrosphere include? Surface water, oceans, seas, rivers, streams, lakes, glaciers, ice caps, groundwater, and water vapor. 97% of the hydrosphere is in form of salt water in seas and oceans, while the rest is in form of fresh water. So you can see the amount of fresh water is only 3%. This major part of fresh water is stored in ice caps and glaciers. The chemical composition of water bodies is variable, but one thing is common: they all contain dissolved gases, mostly oxygen and carbon dioxide, inorganic ions obtained from rocks and minerals, and organic compounds. The composition of seawater is more uniform than that of fresh water. The major components in seawater are sodium ions and chloride ions, and the salt content is quite high. Rivers contain a high level of inorganic components like calcium, silica, and hydrogen carbonate or bicarbonate, and these are obtained by weathering of rocks. Lakes exhibit thermal stratification where different layers are formed differing in temperature. These layers may have different chemical composition. Wetlands may have fresh water, salt water, or brackish water. The composition depends on the location and source of water. Human activities result in altering the composition of water bodies.